Hello and welcome. In this video, we will be talking about ROSbloX. How ROSbloX enable you to quickly prototype the software stack of a new robot, and how ROSbloX let even inexperienced developers create a robot software stack that is easy to maintain and scale. Let's start at the beginning. We have an idea for a new robot. Here's a robot, at least its body. The mechanical components by itself do nothing. In order for the robot to move and do something, it needs to be equipped with sensors, actuators, and run some software. Here is a robot with some sensors, and let's say we wanted to make croc croc. So the sensor measurements must be read and processed in some algorithm, and then commands need to be sent to the motors to produce a croc croc. When developing new robots, it is commonly not clear which sensors, actuators, and algorithms exactly the robot is required to run to be functional. So typically, we do many iterations in the software stack. A traditional robot software development approach is to equip the robot with a powerful computer, and then all sensors and actuators are connected to this computer. The computer runs an operating system, and on this operating system, we implement and run our drivers, tools, algorithms to make the robot function as we want it to. We end up having a monolithic software application running on the robot with plenty of leftover parts from past software iterations, some of them not even being used any longer. It is difficult to manage library dependencies in this monolithic software stack, and we end up having a lot of hidden dependencies between components. Monolithic applications are known to be hard to maintain, scale, and evolve over time. This, on the other side, is a more modern approach to robot software development. The robot software stack follows a modular approach. Its drivers, algorithms, and tools are implemented as containerized applications. This additional layer of encapsulation brings many advantages. For example, independent dependency management for each module, simpler build processes, and improved testability. So, however, developing a robot using containerized applications requires knowledge of this technology, and it is slightly more difficult for inexperienced developers to get started, especially when just prototyping the robot software. So this is where ROSbloX come into play. ROSbloX allow you to efficiently develop and compose your new robot software stack. A robot developed with ROSbloX implicitly uses containerized applications. It is easy to maintain, scale, and upgrade, even for inexperienced developers. Each ROSbloX consists of a physical device, a computer, which runs an operating system. On the system, a single containerized application, driver, or tool is deployed, implementing exactly one functionality. This can be, for example, reading sensor values, interfacing with a motor, or do some data processing. So, in order for the robot to function as intended, the software modules, our ROSbloX, most likely need to communicate with each other. This is very easy to achieve. Connect all ROSbloX with Ethernet cables to each other, and they are automatically able to communicate with each other. For example, sensor values can be read by ROSbloX A. These are then processed to calculate motor commands in a ROSbloX B, and those motor commands are then sent to the motors of the robot by ROSbloX C. We can compose a robot prototype from as many ROSbloX as we need to implement a novel, interesting functionality, like for our robot from before, to make it say croc croc croc. Our now functional prototype is composed of multiple ROSbloX. So we have finished the prototyping of the software of the robot, and now we want to optimize its compute hardware. We don't want to have one ROSbloX per software module when moving forward in our robotics development process. Let's take a look how this is done. Luckily, our robot software stack is already containerized. We even know how much computational power each container requires. We can simply add the required computational power of all ROSbloX that the robot is composed of, select a computer with the required input and output ports, and then we can simply connect the robot sensors actuators to the new computer and deploy our containers on this computer. For a software developer with a bit of experience in container technology, this process is a very simple task. Now, with ROSbloX, we're able to quickly prototype and compose the software stack of our new robot. This robot's functionality is implemented as containerized applications following a modern robotic software engineering approach. The robot software stack is easily maintainable and can be scaled. And the best, when composing a robot from ROSbloX, no knowledge about the underlying software engineering methods is required. So even inexperienced developers can create a great software stack for their robot. Croc, croc, croc. So thank you for watching this video. I'm grateful for any comments, your feedback and questions. Please get in touch.